Welcome to the Adult Basic Skills Professional Development video series. Throughout our productions, we are committed to excellence in adult education and professional development in basic skills instruction. The goal of this video series is to improve the effectiveness and quality of instruction through focused professional development.
The characteristics of the adult learner determine the cognitive strategies that we must use to teach math. They are 1. Linking knowledge with learner experience. 2. Joining skill with content. 3. Linking motivation to cognition. And 4. Using social communities. These are 4 cognitive areas to which instructors need to respond. Instructors should actively seek ways to make teaching compatible with adult learning characteristics. Unlimited strategies are available for us to do this. First, let us look at how to link knowledge with the learner. Knowledge is indeed central to learning. It should be called up freely to solve problems, to interpret new situations, and to aid in thinking about experiences. Student knowledge expands through active and repeated use of new information. This requires a reorganization of their thoughts, explaining of inconsistencies, and building relationships among all their ideas. Adult learners who are able to build knowledge develop confidence in their own ability to retrieve and/or reconstruct procedures and ideas. Make problem solving an important component of every lesson. Illustrate different ways that problems may be described and translated. Translate problems into different modes of communication. Emphasize process. Provide problem situations with incomplete data. Translate real-life problem situations into mathematical equivalents. Estimate solutions. Apply math in other subject areas, such as reading, social studies, science. Use it in solving a variety of real-life problems. Encourage your students to bring in problems and let the class help them solve those problems. Illustrate different ways problems can be described and translated. Instructors must provide opportunities for students to work actively with concrete models. For instance, fold papers, create patterns with tiles, prepare food, balance checkbooks, figure car mileage, solve the problems, check the predictions. They should be taught to estimate their answers, to figure out, does this make sense? These activities are learned to be done ahead of time. Do the problems and check the answers. This way, students are applying their knowledge in a variety of ways, and they check their solutions. Third, meet different learning styles. Learners are encouraged to translate problems into different modes of communication, such as pictorial, symbolic, verbal, or concrete. Teach procedures both step by step, sequentially, or holistically, so that we meet all learning styles. Fourth, use strategies which emphasize process rather than encouraging rote memorization. Encourage students to question how they use new information and how that information relates to knowledge they already have. New information may be tied to existing schemas by pointing out and discussing likenesses and differences. Students should be shown that learning and applying new concepts are no big deal. They are used daily without our even being conscious of it. Have your learners discuss what they do to solve everyday problems. Provide problems with insufficient data. Use patterns to ask questions and draw the student's attention to those patterns so they can learn to question and pattern themselves. A pattern might go something like this. What do I need to know? What process must I use to solve this problem? What information do I have? What information do I need? How can I get the necessary missing information? Sixth, show learners how to translate real-life problems into mathematical equivalents. Instructors in adult education programs can no longer simply give information. We must first ask the question, what daily experiences can be used in the learning of mathematics? Use basic computational skills. Practice using the common algorithms. Decoding written instruction and applying these skills must be done in realistic situations. 7. Require students to estimate their answers. Then verify them on a calculator. Reflect on those answers and test them to see if they make sense. The second cognitive area is the joining of skill and content. Teaching thinking skills should be integrated with teaching math content. For instance, when teaching the measurement concepts connected with area, the thinking skills of comparing, classifying, estimating, analyzing, or predicting should be taught right at the same time. Teachers should provide well-designed programs which help adults learn to give logical reasons, make inferences, recognize relationships, and generate alternative solutions. Instructors must also know how to use questioning effectively. As adults acquire specific math and thinking skills, teachers must provide adequate practice and give specific yet positive feedback. An ideal mathematics course for adult learners enables them to develop and apply higher level thinking skills such as interpretation, generalization, pattern recognition, estimation, and evaluation of alternative solutions. As a warm-up, begin the anxious learner at the level of instruction well below his or her frustration level. And, as said before, relate those mathematical concepts to the learner's own experiences. Instill the idea that mistakes are not only acceptable, but when identified as such, can actually be a valuable learning experience. Urge your learners to ask questions. Give opportunities at the concrete level. And remember, because of the adult characteristics, the more relevant problems are to present and future goals, the greater the impact on their learning. The third cognitive area in teaching math is the linking of motivation to cognition. Adults will not invest energy in learning anything, and especially math, if they aren't motivated to do so. With a long-term pattern of math failure, obstacles to success may truly appear formidable. A need to challenge strongly held beliefs that learning opportunities are not for people like us adds a further dimension to the instructor's task of providing learning situations which provide for valued, successful outcomes. Make math fun. Try not to get too serious about it. Laugh. Tell jokes. Enjoy learning. Have a good time with numbers. Have a good time with reasoning. Your enthusiasm is contagious. The key to activating motivation in math within the adult learner is to continue making progress. Teachers should provide strategies and motivation which provide for thinking, writing, and trying, even when the student's inner voice is shouting, "Quit! You can't do it." The teacher's focus is to provide early successful experiences by assuring students that their uneasy feelings about math are quite common, but they can be conquered. The fourth cognitive approach is that of using social communities. The adult learner has been taught throughout school experiences that working with others is wrong, cheating, if you will. It is time that this erroneous concept be corrected. The latest work in cognitive psychology points to the importance of social interaction as an aid to effective learning in adults. As we've said before, adults bring to the classroom a variety of life experiences and a vast reservoir of knowledge. They have the capacity to help and encourage others. They can model specific problem-solving skills that may be very helpful to their peers. They represent a valuable but generally neglected resource. Here, we are talking about cooperative learning. While specific features may need to be altered to meet the adult learning environment, this approach fosters shared responsibility for making progress. Several students can work as a team to practice math skills. They can discuss and apply concepts. Internal rewards, such as self-satisfaction, are a wonderful side benefit. Application of cooperative learning guidelines provides an excellent vehicle for helping adults who suffer from math anxiety. When 2 or 4 students are jointly responsible for solving problems or completing assignments, no one person is responsible. No one person is in the spotlight all the time. It becomes all right to ask questions or even to make a mistake. There is less pressure to find one right answer or one right way, and it is much more likely that the different approaches will be proposed and explored, paying off in a richer conceptual understanding of mathematics. The instructor, of course, has the responsibility to plan carefully for student success. They must decide who will work together, choosing appropriate exercises for group practice, and guiding adult learners through their early uncertainty in studying and working cooperatively. The emotional support and academic assistance made possible by this strategy is especially important to adult learners. This video has presented the 4 cognitive approaches to the teaching of math with adult learners. First, linking knowledge with learner experience. Secondly, the joining of skills with content showed the importance for realistic knowledge that works for the student by having direct application to life situations. Third, we linked motivation to cognition by stressing the need for continuous progress that provides challenge rather than frustration. And fourth, the use of social communities to support learning among adults was emphasized.